nice to see this large audience interest here. It's a bit noisy here, so let's see why is this noise about. So we are going to talk a bit SR-MPLS. You remember this protocol? So SR-MPLS, but with the control plane based on IPv6 addressing only. So we have tested in EANTC hot staging a couple of weeks ago multi-protocol BGP with the IPv6 control plane. We have tested SRTE with IPv6 hops. We have tested FlexAlgo and delay measurement based on IPv6 addressing. So actually, we haven't used a single IPv4 address in the whole topology, and we reuse MPLS forwarding plane supported for a couple of decades in your hardware. And I will now hand over to Victor to explain what is the test procedure that we are running today.
So today we have two showcases with IPv6 only control plane for SR-MPLS, and we're gonna show you first the on-demand SRTE LSP creating in IPv6 network. Basically, it works in the same way as for IPv4. So if you got a new prefix to the IPv6 next hop, but there is still no tunnel available, this tunnel will be created on demand automatically. And after that, the prefix will be put in FIBA. And the second showcase is about ISIS with IPv6 only loopback and link addresses. And we're going to use FlexAlgo based on delay metric. And to get this delay metric, we're going to use TWMP Lite over IPv6 addresses. That's about test purpose. And now the value for operators. So here, again, we have for SR-MPLS, that's on-demand LSP creation. This auto-creation SRT tunnels will be done instead of pre-provisioning on full mesh. And the second one is single seed label for FlexAlgo. Regarding routing, we're going to use BGP color community. So it is used to tag prefixes to different FlexAlgos or different SRT paths. And in general, I think that this use case could be useful for operators, especially for those who want to reuse their existing MPLS structure so that to smoothly migrate from IPv4 to IPv6. And basically, all you need to do is just replace IPv4 addresses with IPv6 ones. That's all, and I think that could be very simple and elegant solution for smooth migration to IPv6 only network. The next slide, I will hand over to Anton to provide more details about test topology.
Thanks, Victor. Yeah, so this is an animated slide. So this topology you see is very, very basic, and this is actually what some service providers used to have, years ago. So we have a few devices, two PE devices connected to CE devices. CE devices want to exchange IPv4 and IPv6 traffic in their VRFs. And then we have on top three P nodes from different vendors doing the transit of the traffic. And we have metrics everywhere is 10 for simplicity. And now let's add some value to this network, and we add delay-based metrics, the green metrics. Some of them are dynamically measured with the T1 Lite using IPv6 addresses. Some of them, for simplicity, are made, static values like 1 or 100,000. So you could probably already figure out that between the two PEs, the shortest path of this FlexAlgo, because we use FlexAlgo with delay metric-based definition, is going via the hop in the center, the Arista P router. Then let's add some more complexity to this, and we will add fine-grained traffic engineering. These SRTE tunnels that will exist are actually triggered by the MPBGP update. So first, the PEs exchange the prefixes, they send the prefixes out, and automatically your ingress device will create an SRT2 node based on the template that you have predefined. Our template is simple. We use the blue admin groups on the links. So this automatic creation is called on-demand traffic engineering, and this simplifies you the full mesh that you maybe used to create in your network, full mesh of LSPs. So now how it actually works. The detailed test procedure is on this slide, but we of course wanted to show some CLI examples. CLI is always good to see, and with this I will change the display to the CLI of, but I think it's not changing for you, right? So let me quit this mode, do like this. So I hope you can see the CLI now. Russ, can you please show us how Arista is behaving in the role of a B device?
Okay, there we go. Okay, yeah, Russell from Arista. This is as Anton was saying, this is a P node in the environment. So we'll just start to show some of the details here. So let's have a look at ISIS. By the way, we have a lot of aliases here. So these are not the commands. These are just shortcuts. So ISIS, FlexAlgo. Actually, let me start with it. I'll just prove the first piece now is just showing that it's all V6 connectivity. So here you see it's all V6 addressing on the interfaces towards the Nokia and towards the Juniper. And the bottom command there is just V6 neighbors. And if you have a look at the ISIS FlexAlgo configuration, you'll note here that on the interfaces, we are the ones with the static minimum delay metric configured of 1. And then at the bottom there is the FlexAlgo 128 configured, and its metric is the minimum delay. If we have a look at the ISIS database, you'll note here that the top one here is the Juniper, and the default algo is SID ID 303, and the FlexAlgo 128 is 1103. Likewise, on the Nokia, it is 157 and 728. So if you have a look at the ISIS prefix segments, so this is how we again compute reachability to all the nodes. You'll see there the Nokia 157 and 728 at the top, and the Juniper is 303 and 1103. If we have a look at the MPLS forwarding entries, the top one here, and obviously we have an sRGB of 20,000, so it's 20,303 and 21,303. These are the forwarding entries. From our standpoint, we should only be seeing V6 addressing or V6 traffic going across using the FlexAlgo 128. So if we have a quick capture from the data plane here, you'll see a couple of packets. I only captured 2 packets, the top one there being the one for Juniper, 21103, and the bottom one being for the Nokia 2728. And you'll note the inner payload there is the V6 traffic. So this is a packet capture of the V6 traffic going across our min delay link. And with that, I'll pass over to...
Okay, thank you. So now let's look deeper into configuration. So on the Nokia side, we can see now that this IPv6 traffic goes via FlexAlgo 128 tunnel. But if we check the IPv4, VRF, we don't have any rows there. And subsequently, we don't have any SRT tunnel. So let's do the prefix from Juniper side. So now it's advertising to Nokia. And also I will add the prefix on Nokia side for reverse traffic to Juniper. So, and now we can check that the prefix, IPv4 prefixes appeared in VRF, and this is a tunnel, SRT tunnel, it's automatically created on demand. So here is the on-demand admin group next hop to this next hop on Juniper. So basically that's it. And Anton, you can.
Yeah, just a small closing note. So you have seen how to use MPLS forwarding plane with IPv6 addressing in your network. Actually, you can use exactly the same feature set as you would have used with IPv4 addresses. So I think this is all for our side. We don't have time to show you the CLI from Junos, but I am pretty much sure you prefer to have a beer session instead of Junos CLI. So we could maybe switch over to beer.
Right, and thank you very much for everybody who presented here.